Hey guys, it's me Sharon. So today I'll do a new video about periodic classification of elements. So yesterday guys I thanked you about for the 50 subscribers. Thank you guys a lot. So now I'll do a new video, a new chapter of periodic classification of elements part 1. So what do you know about periodic classification of elements? Early attempts of periodic classification of elements we have learned in 9th standard. The first one was of course Rutherford's. So now looking at early attempts to classify elements. We have already learned Rutherford's atomic model in atomic structure. We have already learned those. So if you don't know what it means, you can go check down the video link and let's see the video. So early attempts to classify elements. Many attempts were made to classify the known elements from time to time. The earlier elements are known as earlier, like so to 1800 to 1900, there were a lot of early attempts to classify elements, how they are, what they do, and what is their role in life. So the first one is Proust's hypothesis. He was a Russian scientist. Had According to his theory, hydrogen atom was considered as the fundamental unit from which all elements were made, also known as unitary theory. So Proust, he proposed that every material in the universe is made up of hydrogen, which also includes this mic, my hand, my whole body, everything, literally everything. But only some are made up of hydrogen, like the heavenly bodies such as gas, planets, and everything. But not everything is made up of hydrogen. Plus, there are still some things exist known as solids, and of course there will be no such thing as there are no solids that are made up of hydrogen except aerogel. It is not considered a solid, but it is still considered a light solid. So Proust's hypothesis say that it was a unitary element, which means it consists in all of our daily routine life, just like carbon. Carbon literally you know takes big parts of life in everything. Even our body has carbon. The table has carbon, the board has carbon, everything has carbon. So next is Dobereiner triads. So Dobereiner was German scientist. So Dobereiner classified the elements into groups of three elements with similar properties in such a manner so that the atomic weight of the middle element was the arithmetic mean of the two elements. Example, so if you take the table and the board, so what is in common? Look at the elements. They both have carbon. So carbon is that arithmetic mean. So the mic and my hand, what is both in common? Nothing. So I won't say nothing. There is some, but I'm not sure what it is in common. So Darbarna took for lithium and potassium. So lithium and potassium both are alkali elements, and sodium is also an alkali element. So triads, which mean three elements. So three elements, finding the arithmetic means give one element. So 7 plus 3 by 2 gives us 23. So that's why dot minus is like that. So there are some limitations. There are only like few limitations, not that much. But dot minus triads was not proven completely good because only a few elements are found during these days, still calcium, I suppose. Next one is Newland's octaves or law of octaves. Newland states that when elements are arranged in order of increasing atomic mass, every eighth element has similar properties similar to the first in the musical note. So we know musical notes such as, for America is like do, re, mi, fa, sol, la, ti, do, and for Indian it's sa, re, ga, ma, pa, da, ni, sa. So see, Sarigama Padani Sa. Sa is running, but where is Sa? The Sa is repeated again here. So, Sa. Look, lithium and sodium both they have something in common. What is it? Alkaline metals. These are alkaline earth metals. These are considered boron family, carbon family, hydrogen family, oxygen family, and halogen family. And this only is applicable to calcium, of course. So the Lothar-Meyer's atomic curve